For the beam with loading shown in figure, determine the reactions at the supports. This is hinged support and this is roller support. This is inclined load of 100 kN, inclined at 45 degrees to the horizontal. This is rectangular load of 50 kN per meter, and this roller support is making angle of slope of 1:2 to the horizontal. Now, first resolving this 100 kN force into horizontal and vertical components. Horizontal component will be 100 cos 45 and vertical component will be 100 sin 45. Now, simplifying this 50 kN per meter load into simple single point load, say it as rectangle of width 3 meter and height 50. So it will be 3 into 50, area will be 3 into 50. So single point load will be 3 into 50 equal to 150 kilonewton point load acting at 1.5 meters from this starting point, point C. Now, this is hinged support and this is roller support. For hinged support, there are two reactions. One is horizontal reaction and one is vertical reaction. And for roller support, there is one reaction perpendicular to the horizontal, perpendicular to the roller surface. Now, finding this angle theta, this is got by tan inverse of 1 by 2. So here this is theta, this is 90 degree, this is 90 minus theta, and this is theta, this is 90 minus theta, this is 90 degrees, and this angle will be theta. So writing this theta angle 26.56 here, this RD will make 26.56 degrees to the vertical. Resolving this RD into horizontal and vertical component. Horizontal component is RD sin 26.56 degrees. Vertical component will be RD cos 26.56 degrees. Resolving forces horizontally and equating to 0. Summation Fx equal to 0. HA plus 100 cos 45 equal to RD sin 26.56 degrees, or HA plus 100 cos 45 degrees minus RD sin 26.56, as it is directed to left. So minus RD sin 26.56 degrees equal to 0. So we get equation in solving for this one, this taking this one to right and solving for HA and RD, we get equation in HA and RD, say it as 1. Now resolving forces vertically and equating to 0, that is summation Fy equal to 0. VA plus RD cos 26.56 equal to 100 sin 45 plus 150. So we get equation in VA and RD, and calculating this we get 220.71, say it as 2. Now taking moment of all forces about point A, HA is passing through point A like this through line of action of force, and it will have 0 moment about point A, HA into 0, 0. VA will have line of action of force like this, it will pass through point A and it will have 0 moment about point A, VA into 0, 0. And this 100 cos 45, it will pass through line of action of force like this and passes through point A, it will have 0 moment about point A, 100 cos 45 into 0, 0. And this 100 sin 45 will have line of action of force like this, it passes through line of action of force like this and it will have perpendicular distance about point A of 1 meters, and it will rotate about point A clockwise like this. Its magnitude is given by, moment magnitude is given by 100 sin 45 into 1 clockwise, so plus. Now, taking moment of this force will pass through line of action of force like this, and it will have perpendicular distance about point A of 3.5 meters, and it will rotate about point A like this clockwise. So it will have magnitude of moment of 150 into 3.5. Now this RD sin 26.56 will have line of action of force like this. It will pass through line of action of force like this and passes through point A, and it will have 0 perpendicular distance about point A. So RD sin 26.56 into 0, it will have 0 moment about point A. And this RD cos 26.56, it will pass through line of action of force like this, and it will have perpendicular distance about point A of 5 meters, and it will rotate about point A like this anti-clockwise, and so it will have magnitude of moment of RD cos 26.56 into 5. We have calculated horizontal, we have resolved forces horizontally, and we got equation in HA and RD. We set it as 1. We resolved forces vertically and equated to 0, and we get equation in VA and RD, and we get say it as 2, equation 2, and we have taken moment of all forces about point A, and we got RD value. Substituted RD value in 2, we got VA value, and substituted RD value in 1, we got HA value. Here HA is negative, and here HA value is minus, and it says that what we have taken this HA direction is wrong. We have to reverse this direction. So after reversing the direction, this is the correct value of HA and the direction. We have HA value, VA value, and RD value.